Today we're looking at how to solve rational equations. And my first step when I want to solve rational equations is just like with adding and subtracting, I need to get a common denominator. So looking at my first example, I have an x, a 5x, and another x, which means, since all of them have an x, that's good, but one of them has a 5, which means I need to make it so all of them have a 5. So I need to multiply my first fraction by 5 over 5, and my last one by 5 over 5. So same thing as when we were adding and subtracting. Now I need to simplify. So 5 times 2 is 10 over 5x equals x minus 1 over 5x. 1 times 5 is 5. Now that we have the denominators equal to each other, basically what I'm going to do is ignore them, except for checking it at the very end. So now I'm going to take my numerator of each fraction and write my new equation. 10 equals x minus 1 minus 5. So all I did, once again, is take the numerators and write down what that is. Because if the denominators are equal, then I know to make this whole equation equal, the numerators need to be equal to each other. So that I can solve as 10 equals x minus 6, and then add 6, and I get x equals 16. Now, I do need to double check and make sure I don't get something called an extraneous solution. So if I plugged that into my original, would I be able to do that? Yes, I can have 16 and whatever 5 times 16 is in the denominator. But I always need to make sure that I don't end up getting a solution that makes my original equation equal to 0 in the denominator. So that's it for the first one. Next one, we just make it slightly more complicated. I have 3x squared, 2x squared, and 6x. So right off the bat, I'm noticing that my last fraction doesn't have an x squared. So I know I'm going to need to multiply him by x over x. And when I look at my numbers, I have 3, 2, and 6. So the smallest thing those all go into is 6, which means I need to multiply my first fraction by 2 over 2, and my second fraction by 3 over 3. So I'm going to have to distribute on this first one. 2 times 3x is 6x. 2 times 4 is 8 over 6x squared equals 15 over 6x squared plus 1 times x is just x over 6x squared. Double check your denominator is all the same, so we're good. Now I'm going to write the equation represented in my numerator, which would be 6x plus 8 equals 15 plus x. And I just have a multi-step equation. So if I subtract x from both sides, I get 5x plus 8 equals 15. Subtract by 8, and I get 5x equals 7. And then divide by 5. So my answer is x equals 7 over 5. Now, can I have 7 over 5 on my denominator? Yep, that is fine. So I'm good to go. The other option is at this step, right here, you could say that my excluded value is that x cannot equal 0. So as long as I don't get 0 as my answer, I'm good to go. So once again, final answer, 7 over 5. Now we start to get a little bit more complicated where we have to factor first. So just for sake of ease, I'm going to put 1 as 1 over 1 equals 1 over, I have a GCF. You're starting to recognize GCFs more frequently. Yep, and it leaves me with 2x plus 1. With GCFs, always just double check that if you distribute back out, you get to your original. So 3 times 2x is 6x, plus 3 times 1, which is 3. We're good there. Plus x minus 5 over 2x plus 1. So all of these obviously have a 1 in the denominator, so that's good. But they don't all have a 3, so I need to multiply my first fraction by 3 over 3. And also my last one. And remember, 3 over 3 is just 1, so it's not actually changing my equation. And 2 of my fractions have 2x plus 1, but this first one does not. So I need to put that over there too. 2x plus 1 over 2x plus 1. So once I simplify that, well, I know everything is going to be over 3 times 2x plus 1, so I can go ahead and write all my denominators. And now let's distribute. 3 times 2x is 6x. 3 times 1 is 3. 1 is 1. And 3 times x is 3x. Negative 5 times 3 is negative 15. Now my denominators are equal to each other. Let's look at my numerator. 6x plus 3 equals 1 plus 3x minus 15. So if I do some magic here, I get 6x plus 3 equals 3x minus 14. Subtract 3x from both sides. Subtract 3. I have that my x is negative 17 over 3, which will be totally fine in my denominator. So that is my final answer. Lovely. Okay, this next one we have some lovely factoring to do. Okie dokie. So my first one, he's good to go. Three equals p minus 6. I can factor a GCF over here. P times p plus 3. Whoops, that's a minus. And I'm going to put that in red so I don't get it. 5p minus 15 over p times p plus 3. Now the top of my last fraction, it does have a GCF, but I'm not going to bother taking it out because it's not going to cancel with anything in the denominator, so that would just make more work. So let's look. All of these have a p plus 3. Good. But only 2 of them have a p, so I need to multiply my first fraction by p over p, which will simplify to p over p times p plus 3 equals p minus 6 over p times p plus 3 minus 5p minus 15 over p times p plus 3. And just to make my life easy, I'm going to go ahead and say what my excluded values are, which are 0 and negative 3. All right, let's solve my numerators. P equals p minus 6 minus parentheses 5p minus 15. So p equals p minus 6 minus 5p plus 15. combining like terms on the right side, and I get p equals negative 4p plus 9. Add 4p to both sides, and that gives me 5p equals 9. Divide by 5, and p equals 9 over 5, which is not one of my excluded values. So I am done. And that's it. We'll do some more complicated ones on Friday.